Okay, in this video, we are going to first review how to divide fractions, and then we are going to do homework problem 7.2, question number 8. So remember how we divide fractions? We multiply by the reciprocal. And order matters in division, which is why I have been using DD division by the denominator, right? A D and a D, to help ourselves remember that. So for an example, 2/5 in the numerator and a big old fraction bar 8/5 in the denominator. This is 2/5 DD. What am I dividing by? I'm dividing by 8/5. Now, how do I divide fractions? I'm going to multiply by the reciprocal of what I'm dividing by. I'm dividing by green. I'm dividing by 8/5. It's that second fraction that you need to flip. So I'm going to multiply by 5/8. Now it's back to familiar territory. We multiply fractions straight across. I'm not going to write this as 10/40. I'm going to leave that 2 times 5 as 2 times 5, and that 5 times 8 as 5 times 8, so I can acknowledge this times 1 that's happening right here. We get 2/8, which is a 1/4. Another secret times 1. So the work is identical in terms of its structure, but things look different because these expressions are more complicated than just these numbers. But to divide a fraction, you're dividing the second one. How do you do that? You multiply by its reciprocal. I want everything in factored form so I can acknowledge my secret times 1s. So now let's go ahead and do question number 8 here. I don't even care. I'm not even thinking about my first fraction. I'm just going to copy it down. In fact, let's do this quick style. Just copy that down. And it's this second fraction that I'm dividing by. How do I divide by green? I'm going to multiply by the reciprocal. I'm going to go ahead and flip that fraction. So now in the numerator I have 3x squared plus 14x minus 5 in my numerator, 6x squared plus 7x minus 3 in my denominator. And now it's just like the problems we were doing previously. I'm going to go ahead and multiply fractions straight across and then look for secret times 1s. Because I know I'm going to look for secret times 1s, I'm going to help myself out a little bit and do some scratch where I go ahead and I factor each numerator and each denominator. I'm going to just write that down with some new color. Okay, so all I did is I recopied this line down without the red, and now I'm going to compartmentalize my thinking. I'm going to just factor yellow, then I'll just factor green, then how about blue? Then I'll just factor blue, and I'll just factor pink, and allow myself to just think about those 4 problems separately. When you get really comfortable with factoring, feel free to do this all at once, but I'm just trying to model a strategy. So for yellow, 2x squared minus 7x minus 15. There's no GCF here. The only thing that divides into 2 is 2 besides 1, and it doesn't go in evenly to minus 7 or minus 15 for that matter. Now you can either do the AC method, which we've done before in class, If you liked that, remember that you're looking for two numbers that multiply together to give you A times C, and then add up to B. And what do you do with those two numbers? Those two numbers are telling you how the like terms were combined to get minus 7x, and then you do factor by grouping. Alternatively, you can do strategic trial and error, which is what I'm going to model right here. So because 2 is prime, I know that this is a 2x times an x, right? 2x times x will give me 2x squared. And then there's not that many numbers that are going to multiply together to give me minus 15. Because it's multiplying together to give me a negative, I know one of these things is positive and one is negative. So we could have, for an example, a minus 5 times times a positive 3 would give me minus 15. And then we'd have to multiply out to see if that is the correct one. Order does matter here because 2x and x are different. So having a positive 3 over here and a negative 5 over there is a different option. We also could have the 5 could be positive and the 3 could be negative, and order matters. So we've got those 4 choices. And then we've got 4 more choices when we work with 1 and 15, right? So there's a total of 8 things to try. Let's go ahead and just try this first one. What if we put a minus 5 and a positive 3? So 2x times a positive 3 would give me 6x, and minus 5 times x would give me a minus 5x. When I add those two together, I do not get minus 7. So I know it's not minus 5 and a plus 3. I also know that it's not going to be positive 5 there and a negative 3 here, because then I'd have minus 6x plus 5x when I multiply out. Those like terms do not add up to minus 7x. So maybe the 3 is over here. Maybe we have a minus 3 and a plus 5. We'd get 10x when we do 2x times 5 minus 3x. Oh, that's close. 10x minus 3x is positive 7x, and I need it to be negative 7x. So what does it need to be? It's going to be a positive 3 and a minus 5. Negative 10x plus 3x is minus 7x. We factored that beautifully. So yellow is yellow. All right, let's also, the green one isn't so bad, right? That's that delightful difference of perfect squares pattern. 25 is 5 squared. So this factors into, I'll even write that. This factors into x minus 5 times x plus 5. Or if you prefer, x plus 5 times x minus 5. Order does not matter in multiplication. Right? Kind of nice having these boxed. I'm just allowing myself to think about the factoring of each 4 of these separately. 3x squared plus 14x minus 5. Unfortunately, there is not a GCF here because 3 does not go into 14, or minus 5 for that matter. And again, either do the AC method, which results in factor by grouping, or strategic trial and error. I'm going to do strategic trial and error because 3 is prime and so is 5. So there's not too many things to play around with here. I know the 3x squared came from a 3x times a 1x. And now for things that multiply together to give me minus 5, we can have a positive 1 and a negative 5. Order matters here because 3x and x are different from each other. So I could have the minus 5 here and the positive 1 here. Or maybe the 1 is negative and the 5 is positive. And again, order matters. So there's only 4 things to try. That doesn't seem that bad to me. So that's going to be my strategy. Let's try the first one. All right, so 3x, oops, I didn't want a highlighter. There we go. 3x times a minus 5 would be minus 15x plus a 1x, and that doesn't add up to positive, 14x, but it adds up to negative 14x, so I'm super, super close. We want the 1 to be negative and the 5 to be positive. So we would have 15x minus 1x. Yes, that's my 14x. I'm happy. Okay, so blue is blue. And then lastly, pink. And pink, maybe you want to do it the AC method. I'm going to stick with trial and error. Pink has the most choices here with that 6 being composite. That 6x squared could have come from a 3x times a 2x. It also could have come from a 6x and a 1x. Now, trial and error, again, isn't super bad here because 3 is prime. So we've only got, and order matters here because these are different from each other. So at most we've got 4 things to try with this setup and 4 things to try with this setup. So a total of 8 things to try. My recommendation is to just pick one of them. And now I'm going to run through, is it a positive 1 and a minus 3, or a minus 3 and a positive 1? Same thing with negative 1 and positive 3. I'm going to run through those 4 choices before I decide it's not a 3x times a 2x to give me 6x squared. Okay, so how about plus 1 minus 3? Here we would get minus 3 times a minus 3 is a minus 9x. 1 times 2 is plus 2x. That's minus 7x. Oh, we're super close. I need it to be positive 7x. So in fact, I know it's a 3x minus 1 times a 2x plus 3. Pink is pink. Yeah? 3 times 2 gives me my 6x squared. 3 times 3 gives me 9x. Minus 2x is positive 7x. And minus 1 times 3 is minus 3. Now I'm going to go ahead and just multiply fractions straight across. We've got yellow times blue all over green times pink. And then acknowledge our secret times 1s, and we are home free. Yellow is these 2 objects multiplied together, times blue is these 2 objects multiplied together. All over green, these 2 objects multiplied together, times pink, these 2 objects multiplied together. I am going to get color on here, but I want one without color saved, right? So here we just multiplied fractions straight across. Yellow times blue all over green times pink. And now I'm looking for my secret times 1s. It's super, super important that all of this is factored. The second I change one of those times signs to an addition or a subtraction, this is not a legal move. I need it all to be factored because I can say, hey, times 1 doesn't change anything. Let's get some color. So I see that we've got an x minus 5 all over an x plus 5 factor. There's a little times 1. Maybe we even write them, there's going to be a lot of them. That's a times 1, no change. We've also got a x plus 5 and an x plus 5. There's a times 1. We've got a 3x minus 1 all over a 3x minus 1. There's a times 1. And then we've got a 2x plus 3 and a 2x plus 3. Oh my goodness, everything disappeared. Is my answer 0? No. What's up here? If I put a 0 times 0, what's 0 times anything? It's 0. And same thing with the denominator. Right? This isn't 0 over 0. What is the one number you can multiply and not change anything? It's 1. The numerator is the numerator times 1. The denominator is the denominator times 1. Here is my answer, 1 over 1, which equals 1, and we are done. Okay? And for future classes, you would make a little note about these places where you were originally dividing by 0. So x couldn't be 5, or minus 5, or 1/3. If x was 1/3, that guy would be 0 there. Or minus 3/2. If x was minus 3/2, that guy would be 0. All right, let's go onto our computer, enter a 1, and see that we are correct. Hit submit. And yay, we did great. I hope this video was helpful.